Hey, this is Dr. Troutman here. Back when I was teaching earth science, we would do presentations every Friday. We called it Article Friday. And students would find some research, find some news story, and then share it with the rest of the class. We would build on this over the course of the year so that eventually by the fourth quarter, a lot of students were taking over an entire class preparing it. I'm not going to do that here, but I did want to take a moment to just share some recent news that came out. If you want to take a moment, we can learn something about science, hopefully a little bit as well. So a bit of astrophysics. It's a way to distract, take a break from what you might be normally doing. It's a way for me to take a break and dive into some of the stuff that I've been passionately researching in a previous life here. So let's take a look. If we dive in, you may or may not have seen a recent news story. This comes up every once in a while, this idea of Earth-like planets being detected here. So this was posted a day ago. So I think this was on May 12th in 2020 coming out. So this super Earth discovered with an Earth-like orbit. So let's dive in. You can read the article and get some summary of what the research is showing. But what I want to point out is that at the end of these articles, there's usually some sort of text here that says something like this. The research here is described in blank. And they link directly to this paper. So this is the actual primary research that the researchers are presenting. And then articles like this are summarizing that research. So if you click on that, you will go to a really complex looking paper. So this looks a little bit more complex than what you might need to understand, but we have the title here up top. We have the author list, and all of these subscripts or superscripts in here reference the institutions that they go to or they are professors at. And we can see some important pieces of information such as the date here. And down here, the abstract. The abstract is the summary. Most science journalists will read the abstract and use that for the basis of their articles. The abstract might be a little bit tricky to read, and it is can be complex, but we're going to view it as not so complex. I'm going to break this down a little bit. So we see the title. This title is saying this really complex thing, OGLE 2018 BLG 0677L, capital L, lowercase b. What does that refer to? So this is an observation of a star. This is observing some sort of either an event or a star. And the event or a star will just be cataloged based on OGLE. The OGLE is a telescope, the year that it was observed, and then this later part will be either where it's looking. In this case, that's the BLG. So it's saying it's looking at the Galactic Bulge. And then down here, it'll just be a catalog of an event. So this is the 677th event, either of this item or this object, or this is the 677th star that they observed. And then these other symbols are just part of that catalog name. So astronomers aren't very clever, and we just kind of name things based on 001, 002, 003, keep going with those. It makes it simple. So this is what I wanted to get to, the super Earth near the Galactic Bulge. So how did they discover it? So there are a number of different methods for detecting planets. We have things like transit method, where we look at light being blocked from a star, radial velocity, but the one that this one observed is microlensing. This is an interesting artifact of gravitational lensing, where gravity from a star will actually bend light around it that acts just like a eyeglass lens or a contact lens. So if you think about a lens, You have a lens here, and light is coming into the lens, and it gets focused down onto something like your eye or onto a single spot. Well, the same thing happens if we're looking at, can observe some sort of background star, poorly drawn star, but you get the idea. We're looking at this star, and just as a reference here, this symbol is often used by astronomers to represent the viewer or the observer here. So we're looking at this background star, and we're paying attention to the background star, not in isolation. We'd be paying attention to a bunch of stars in a field, and we'll just kind of monitor the field of stars. And then what happens is, if things line up perfectly, we have another star that is kind of moving through space, moving through the universe, through the galaxy, and it might pass between the star, the background star, and us. Now, that is not going to block the light. This thing is way too small. The star that's in between is way too small to block the light. But what does happen is, all the light that would be emitted from this background star, some of that light is bent from the gravitational force of this star. The gravitational force of the star actually bends space around it, so that light that would have traveled out to the universe now bends and comes towards us. And again, this combines with the light that is passing by the star and towards us. So what happens is, if we look at the level of light, or the brightness of the background star, so the brightness of the background star over time, we actually see that the brightness of the star would be constant. And then we see this increase in the brightness and then a decrease in the brightness as it passes by. This effect of the increase in the brightness is gravitational microlensing. This is microlensing. Well, if we look at the bump of that star, we can analyze what is in that, the system that is in this object here. This, whatever is in that system, whether it's stars and planets, we can look at the bump and analyze the bump and see what the system has in it. So if there's a lot of mass, we'll be able to detect that. If the star has a star and a planet, there might be some wiggles in the bump. As the star and the planet pass by, we might see some bumps within the bump, which is kind of interesting. And that's exactly what these researchers did. So going back to the article, they looked at the bump and the bumps within the bumps, and they found out that we have a planet with a certain mass. Now we take a look at the symbols. The mass of this planet is 3.96, and here's this nice symbol, M with a circle and a cross in it. That represents Earth masses. So what this is saying is, the planet that they detected is around 4 times the mass of Earth. So that's where they get the super Earth in the title. And what is it moving around? Well, we actually can detect what it's moving around. We look at the host star, and we look at 0.12 and this little symbol M with a circle dot. Well, if this on the left side was a mass of Earth, this circle dot is going to be the mass of the sun. So what we found is a 4 times, something that's approximately 4 times the mass of the Earth, moving around something that is 1/10 of the mass of the sun. That's super interesting. This is a pretty low mass star. Now there's other information that's embedded in here, but that seems to, for now, is a little bit beyond what I wanted to introduce. I just wanted to take a second to talk about this idea of gravitational microlensing and how we know what we do about other things. So if you're curious, you can go to either the article or to this original article, the original research article, and we can talk about it. I'd be happy to talk about it one-on-one. So if you have any questions, or if anything wasn't clear, just send me a message through my TJS or email, and I'll be happy to answer it. Hopefully we can do this again. I'll keep an eye out for any kind of interesting space research, at least for right now. That's where my interest is leading me. So if something comes out in the future, I'll be sure to post another video. All right, thanks.